Okay, class, what we're talking about now is memory and learning. Really, they go hand in hand. Memory and learning. Okay, memory is the storage and retrieval of information. In this memory aspect, we have first the storage occurs in stages continually changing. The processing accomplished by the hippocampus and surrounding, and the memory traces chemical or structural changes that encode memory. So what do we know about memory? Memory involves forming brain synapses. So in other words, when we memorize something or learn something, we form brain synapses. Now, I always talk about in class that let's say Joe is a gentleman that took algebra, and he's excellent at algebra. Okay. Jim, however, is not good at algebra. Okay. Both end up taking calculus. Since calculus was derived out of algebra, it's kind of like a continuous math, then Joe, who knows algebra, won't take him long to learn what? To learn the calculus. Whereas the other gentleman, it will. Because he's got to form synapses. But all the first person that knows it well has to do is just go through the existing synapses he's already formed in his memory and learning, and you just add to it. Just add to it. So in other words, it involves synapses. Memories is stored in different areas of the brain depending on what kind of memory. There's short-term and long-term memory. And there's a declarative memory, which is more of a factual, an experiential memory, which is from experiences you've had, and skill memory, like learn to play a piano and so forth. So there are different kinds. Okay? So there are two stages of memory, the short-term memory and the long-term. The short-term and the long-term memory. So let's go here. Okay, memory is a property of organism which ensures impression of connections between the environmental events and accumulation of living experience. The brain areas involved in neuroanatomy are the hippocampus, the amygdala, striatum, corpus striatum, mammillary bodies are supposed to be. So there are different areas, as I alluded to, involved in different types of memory. Okay. Duration of memory, working memory, seconds to minutes, depends on attention and avoiding other stimuli. So that's kind of your working memory. What are you doing right now in the next few seconds to minutes? Okay. Then you have the short term, minutes to hours. So in other words, if I'm working and we're working on something and I'm looking over a document, that's my working memory. That's right there in front of me right now. And I'm working on that. Some of that I might push into short-term memory. Which lasts for minutes to hours, requires motivation and attention. I have to think pretty hard. And then some of that, perhaps if I really concentrate, I might be able to push it into long-term memory, and it'll stay around. Okay? That long term is in different areas of the cortex. So again, we go back and we say that these are the areas involved, the hippocampus, amygdala, striatum, and different areas. Amygdala, remember, is part of the limbic system, so that would give an emotional type memory. Okay? So it just kind of depends on where it is. It's believed to involve in declarative memory. See this emotional memory in the amygdala, part of the limbic system. So we go back. So we have working memory, which is right there, what you're doing right now. So you're in your working memory right now. Now some of that you'll take to short term of what we're doing now. And some will incorporate, if you learn it well, into long-term memory. And they'll be a part of you. Now, you still have to go back every time and refortify long-term memory. All right. So you have a sensory input that goes into short-term memory. Okay? Short-term memory. Now you still have a working memory, but this is not showing that. The short term, then what will happen? Repetition promotes retention. So if you keep looking at it, and then some will actually push the long term. If you do enough repetitions, it'll push the long terms and you'll consolidate the memory. Okay. All right. Permanent loss due to neural fatigue, shock interference. So in other words, if you're learning something like you're learning now, and you don't really know it, and all of a sudden, somebody comes in and says, hey, you got to do this for me. You pretty much going to forget it. Okay. You definitely going to forget it if it was in working memory. Because something else has interfered with you. See, remember, if something else interferes, avoid another stimuli. So that's what we're looking at. All right. So here are some of the areas of the brain. Now, when we get into what we call we have the short term, long term. We already talked about that. When we get into declarative memory, now declarative memory is what you really are doing now. That's a factual memory. That's that declarative memory right here. Concepts and so forth. And here's kind of its pathway. Association, medial temporal. That's declarative. Explicit facts. Skill memory is when you're learning to, play the piano or whatever like that. Then experiential memory. See, skill memory is you learning to swim or to play the piano or to play the cornet or something like that. Experiential memory is more from the fact that you went through something. That experience that you get. So you really kind of have an experiential memory, a declarative memory, which is more factual like you're doing now, and then a skill. So experiential memory would be, okay, we talk about something, then we do an experiment, and you physically do hands-on, so you learn it that way. You physically do hands-on, so you see it that way. Okay, which gives you more sensory input. Okay? So, different types of memory. So we go back to what I said initially, and that involves brain synapses. That's why we call plasticity of the brain. Plasticity of the brain is forming memories. Now, I've got a video that I want you to watch, not just mine. It's one I'm putting in there that I think is pretty good. Kind of upbeat video to talk about this, to kind of give you more, because remember, this also involves learning, and I know that that's what you're trying to do. So you want to kind of study on it to see, well, how do you memorize things better? How do you learn quicker? All this stuff like this. It's good to talk about it and see it. So in other words, there are different areas of the brain, saying that skill memory is located in a different area of the brain. Like here's the premotor cortex. Remember premotor cortex? We had the primary motor cortex, which is that. And I said premotor would be where all of a sudden you're playing the piano and this premotor would send the signal as to which fingers to do next, and then which fingers to do next, and then which fingers to do next. That's that premotor cortex right there. That's skill. But over here, it would be more of the hippocampus area for more of declarative memory and so forth. Then remember, the amygdala is more for emotional memory. So you can kind of read on it and get an idea there. Let me hit one more thing in this chapter, and that is different things that can happen to the brain. Traumatic brain injuries, concussion, temporary alteration in function. You've heard of a concussion, contusion, more of a permanent damage. See, a concussion would be like, for example, okay, you're in a car accident, your head goes forward then backwards. Well, what's it going to do? The front will hit the inside the skull. I mean, the cerebrospinal fluid will help some, but it's still going, it depends on how hard, then it'll go back. And that's kind of that. But now if you have a contusion, that means you've actually suffered more of a physical damage to the brain. Concussion is more of a temporary. So it just kind of depends. Then a subdural or subarachnoid hemorrhage. Subdural would be underneath the dura. Subarachnoid would be underneath. That would be where the cerebrospinal fluid is. Okay. And it may force the brain. It may be so much pressure that it pushes the brain through the big hole, the foramen magnum. We call it herniation. Herniation basically means when you push something through an abnormal area. The brain can swell. Cerebral edema, if it was to hit different areas, it could swell. Okay. In that case, sometimes what you have to do is, they used to bore holes in order to relieve the pressure in the brain. Bore holes in the skull. CVA, new name, cerebrovascular accident for a stroke. And basically what that has to do with is obstruction of some of these blood vessels here we talked about. They could do that. A TIA is called a transient ischemic attack. That means that temporarily something happened to block and then it went away. So that's what we call a TIA. TPA you won't really understand till AP2. That helps dissolve blood clots. TPA helps dissolve blood clots. Tissue plasma, and I'll explain that in very good detail in AP2. And then degenerative brain disorders would be like Alzheimer's, Parkinson's. Things of that nature there. Okay. So that's kind of what we're looking at in this particular. Okay, we'll close here, and you can read on some of this. Thank you very much.